We're going to continue looking into the source code that draws vectors eyes and face. We previously looked at a thread that receives frame buffer data of previously drawn information and then passes that to the LCD display. This time we're going to dig into the code which receives the animation file data and see what it does with that. Start by opening up the header file here and looking at that. As always, it has a good description block in the top and a good synopsis. Has that protection against multiple includes. And here there's much more headers that it includes. It includes the types. It has some sort of math that it's going to be involving for points. The vision engine, again, probably for the image buffer format that it will draw to, using the same tools that the vision system uses. I believe that they use OpenCV to do drawing and text, as well as processing images. Configuration file, we discussed that before. The types that are used by CLAD to represent some sort of settings or perhaps configuration of the face. Don't really know yet. We haven't really dug into that. Console interface, so the settings for the face renderer and procedural face and how it does things can be tweaked and watched and debugged. And some logging tools here. What we see next here is bound defines that are used to configure the procedural face module, or at least this one. This is a little surprising. I would expect normally these to be in a separate config file, so there's config files which just do nothing but choose features or set the parameters for the features that are used. That way you can have different people adjust them or set them up for the application, or if it's been adjusted for different hardware, it would be in the header file. They put it in here, which suggests that there's probably only a couple owners or a small team that was working on it, and they were getting it set up, but they didn't really make it configurable on the big scale. So let's look at some of these. The noise feature, which we haven't looked at, but I suspect is used to kind of take away some of the banding from gradients and kind of add a little bit of noise or texture to the eye when it draws it. That kind of makes it look a little bit more smooth or natural, and takes away some of the artifacts that an LCD might create. And I don't know what they mean here by enabled as num frames 5. We can probably look that up when we get to the eye renderer. It probably is referring to how often they add noise to the frame. Animated saturation. So the animation file, it looks like that they were thinking that the animation file could define some saturation for how the eyes are drawn, but they've disabled that here. Either they found that it wasn't working in future experimentation, or that's for the future, or perhaps some other reasoning happened. But they do let the eye saturation get set procedurally through some sort of C++ API. They say only through that, which seems to indicate they were tuning it and probably used the saturation, I would guess, as part of one of the feature settings. So the eye glow, I thought the eye glow was enabled just by looking at it, that it had a little bit of a blurring outside of the eye and some of the hotspot. I'm guessing that this is either a separate feature or that this feature has been adjusted a little bit over time. But they've since disabled it. I'd be curious to know what that actually does. Anyone who wants to configure and tweak and adjust and customize the eyes, they'd want to adjust these next two. So they would want to maybe change the glow. And then the scanline feature, which makes it look like Cosmo. We saw that in the animation file when we all looked through the FBS definition. They let the animation files define some features that could make the eyes have raster scanning looks that made it look very old terminal TV set like, and gave it Cosmo's characteristic look. But they have that feature not even compiled in, it looks like here. We'll probably see that as we go along, but it could probably be turned on, and then using either a global variable here that might be a console variable, or the animation files that could perhaps be customized some more to kind of give you some unique looks to the face. Scrolling up here a little bit, yeah, so they're including, it looks like they're going to include something to read JSON values, interface we saw before to Oh, no, it's a different namespace, cannedAnimLib. So something there to draw the procedural face, dating back probably to Cosmos days. Then some utility functions here. These are the console functions and variables, just declaring that they'll provide some. Here in the vision thing, they are providing some utility functions to manipulate hue and saturation of the, probably computing what those pixel colors should be based upon a hue and saturation number and turning that into an RGB value. External interface, don't know quite what that is, but this looks suspiciously similar to the previous kind of elements where it might be used to pass the procedural face information onto a later stage to draw it in order to render it. The scanline distorter, we can probably guess that that's going to what creates that Cosmo-like look. And then here's the procedure face. This is the module that we'll be looking at today, mostly in the C++ file. They defined a couple of constants here. It's interesting. So they take the pound define from the config and turn it into a constant here, perhaps for type checking reasons or perhaps for some other reasons that they didn't make a comment on. What we also see here is they hard-coded in the eye height and width when it's at its normal kind of size. It looks like here they just scaled it up from Cosmos. Kind of surprised. For maintenance purposes, I would normally also expect this to be part of the a config file, a pound define in a config.h file, along with the LCD display to kind of set it there. But it could have been one of those things they were adjusting and working on and it never quite got generalized in that fashion. So then we see down here hue and saturation defaults. Those are, again, I would expect those to be a config thing, but that's okay if they're just a default and they get overridden by an animation file. Don't fully know all that they're doing here, but what they've done with this using is made a convenience with the namespaces and naming there so that they can refer to types without actually having to use the lower level C type. They can probably change, if they wanted to, values here from this 32-bit float to perhaps a double or to an int or even a short int. And then similar, they probably just made for shorthand, instead of typing out procedural I parameter every time, they just use parameter to refer to that type. Looks like the parameter for the eyes, they're kind of defining how they'll handle that here as a C++ array of, and each one will have its own parameters. Not fully versed enough in C++ types like this to know everything that's going on. They use an enum to refer to the left and right eye. Interesting here, the note. So when reading the code, this refers to the left and right on the screen, not from the Cosmos or vectors perspective. And then here we see a lot of the procedures and methods that they'll define. They have a method here to probably reset the data inside for the parameter face, how it would draw the eyes. Looks like something here that might set it up for a blank face or perhaps define what the blank face is. Something to reset it to go back to a blank face. Now this surprised me a little bit here. They have two of these. I was expecting config.h one of two things to happen here. Either in the config.h they would select initially while in developer mode to allow reading from JSON files, and then that would be commented out and not included, just to reduce a lot of complexity in the compiled code. Or more specifically, my other guess was that the flat buffer system would be reading the JSON files. But it looks like flat buffers does not read it, and they have two separate interfaces here to read the two different file formats, even though they're very closely related. That surprises me. And then there's an equivalent procedure here which lets it set from the values explicitly from probably the C++ code, which is used to create the blinking and darting eyes. I don't know what this set from message is. Just as a guess, I'm going to say that perhaps some of the other application software, perhaps Vic Engine or the communication to the application, the mobile application or SDK apps, they can send face parameters, and those will get passed to the animation Vic Anim, and it will draw them. So, okay, here's where it's kind of getting the eye positions, at least where they would normally be until the face is tilted or something, is my guess. And then here they let you set each of the parameters. They don't actually have a separate procedure for separate getter or setter procedure for each of them. Instead, it looks like you have an it says which eye and then the parameter index or some sort of code for the different parameters. Judging from the work that was done on reverse engineering Cosmos face, there can be quite a large number of parameters for each of the eyes to control its shape and height, width, curves, and all sorts of things. I don't know what eye parameter array would be, but this other set parameter seems to be kind of similar where instead of it setting an individual parameter, it's perhaps passed a whole array of them, possibly from one of these other procedures earlier. Set face angle, so it lets the face be tilted to kind of give a perception of tilting the head or eyes around. And then it lets the eyes be moved from the center, so that's interesting. I wonder if the set face position keeps centered. I wonder what that does. And here they have a helper procedure to change the scale so the eyes can get smaller or bigger. I don't know what the use there is. We'll probably find out as we go along. Here's the scanline ones where they let the software or the animation file perhaps set how much that raster scanline would appear dark or not appear at all. Some color setting for the eyes. Don't know what's going on with the get hue image. Same for get saturation. It looks like they are letting some color get access to an image buffer of those parts, though. Procedure here to manipulate this image scanline distorter. So interpolate here as a good guess. I'm suspecting that this procedure is used when they're given two different keyframes, and then some of the transition there, how it kind of computes the intermediate frame between the two. But it could be used in another way. They say faces. I wonder if I wonder if they mean by faces keyframes. Here's an interesting procedure. This is really kind of important to the character. It lets the eyes look at a specific thing in the distance, and I bet you that is used when Vector's looking around or looking at somebody that it sees in its camera, and that this helps keep eye contact. Let's see here. Don't know what combine is. Enable clip warning, it says for unit tests. Getting bounding boxes probably relates just to management of drawing. Looks like a startup procedure here on this register face with console variables, which is probably used when this is first initialized to connect into the rest of the WebViz console var system to let the web-based developer tools access it. And we see some instant variables here. So looks like these are buffers to hold the separate out the hue and saturation frames or portions of the frame. Looks like this is an array to hold the many parameters for the eyes. Something to let the scanline distorter be a separate class instance that it just connected in. And then here's some of the key face parameters, the high level ones where it kind of had the angle and how big it is and where it's centered, as well as in this case an optional opacity for it, and then the color to draw the eyes in. And then the rest of these are probably, these are debugging and helper methods to link with the rest. So, and then down here we have, for convenience, they put a lot of these as in the header file, these methods, and made them inline, but they basically are the getters and setters for the parameters that we saw declared before. They're just internally moving them into the appropriate array or instance variable. In some cases here, they are checking the values for sanity, especially on the scale. So if one were to make a tool that went through and checked the animation file for correctness, they would want to make certain that these parameters for the face scaling are the same as this or within these bounds. Similar for the scanline opacity, they have another one where they check the range, and so we'd want to check the range if we were to make a tool to look for problems in an animation file. Again, more getters and setters for the other colors and other aspects of the display. Now to C++ files. What we see here is the usual headers in the top, but notice the date is much older than the previous drawing thread. Didn't notice that in the header. I must have missed that. So this is probably dates back to the earliest days of Cosmo when they created this, and then they just separated this module out and wrapped it for use in vector on the actual vector itself. A bunch of the headers we saw before, namespace. They're giving default values to those method and instance variables, and then they're creating some buffers here, one to hold the hue plane and one to hold the saturation plane. I'm not fully sure yet how they're drawing all this, but they perhaps give the initial shape as in terms of just hue and saturation, and then perhaps later on give a gradient to give it a rounded look in value space. That's just a guess. We see the console group name that they did for convenience. Perhaps this is a part of their style of how they're going to group these console variables. Let's look at here. So we have a console function. I mean, there's a lot of ceremony right here, but the key thing here is a console function that would probably be available to the web developer tool. More ceremony here to actually get to the internal here we go. That's probably the procedure. And the name is probably called procFaceHue. It's probably on the web tool. I actually haven't looked into this. There's probably one where you can just give it a single parameter of the hue and call this. But all this ceremony that you see around this is C++ wrappers to get to this, actual method or procedure that they can call. And the same thing for, saturation. So console function, saturation. So yeah, probably another function that the web tool can call to set the saturation. Here is their methods that they can do that. So the function gets called, it gets what's called a context ref, which is not unusual for many things. It's sometimes called a hint, but it kind of has all the information about what may have been passed back and other items. So from there, it gets a float for a parameter named hue, and gets that, and then it'll just internally call the setter method to set the hue, and the same for the saturation there. And then here, there is the option for a console variable if the scanline feature is enabled, that the WebViz or web interface lets a person change different default scanline opacities, probably to try tuning it and getting it adjusted dynamically to see what really works well in the particular displays that might be being investigated. They have another anonymous namespace. I'm not real clear why they didn't have those in this anonymous namespace. They could have. Especially this one. It would seem to be consistent, but they didn't. Oh, I see why. Extern. So this isn't actually being declared here, or excuse me, it isn't being defined here. It's actually in a separate C++ file, probably one for implementing the scanline, and it's just an extern. It's not real clear from this, but having gone through this a few times, I think that's what's going on with this extern. In fact, I do know that's what's going on with that extern. So they have anonymous namespace where they're defining the face parameters in here that can be accessed by the web tool. So eye spacing when it kind of is relaxed. I don't know all the parameters here, but this is probably the range. So this is probably 92 is the default, and this is probably the minimum and maximum range for this. Okay, so all right, we now have a big lookup table, it says. This looks like it's probably going to be the acceptable ranges and default values for each of the eye parameters. It says we use the magic of full enum array checker to guarantee types. That is going to be interesting. So they have an enum here for the different kinds of ways of combining the methods. I don't know what that quite means. But probably as we get into it, we'll probably understand a little bit more into it, how some of these pieces go together. Then here's kind of a structure that kind of gives some idea of what it means to be that kind of parameter. So whether it's an angle, I don't know what if it can be unset. Don't know what that means. Default value. And default value of combining is unset is unclear. But we see right here the acceptable minimum maximum values. That makes sense. And then there's a combine method, which I'm guessing is if you're drawing the eyes and it has a shape and then it says let's tilt the eyes or let's move them left or right or perhaps shake them, that might be some of the combine method's role. I suspect we won't find out for some time until we get to other modules that see how they use that. Here's this table. So this kind of looks like it has left columns, all the parameters, and then the structure up there of whether or not these things are angles or not. So there's only a couple of them that are angles. These two are angles. Whether or not it can be unset, and only saturation, lightness, glow size, hot spot, and glow lightness can be unset. I wonder what that means. Then it has the default values for them and the minimum max range. So this table could also potentially be useful information if when we're to kind of make that animation file checker and went and checked the kind of problems and warned that, okay, your handcrafted eye animations, these values are out of range, and gave some sort of a hint as to where that was occurring in the file and what that meant. So many of these look kind of angles kind of thing. Would be sensible limits as well as the display. So it looks like the display might be centered. Yeah, the center is 0, and then it's kind of offset into the center display. So it's the left eye might have a negative position, the right eye might have a positive position, as opposed to the center being the half width value that we would typically see in just a bitmap. So they'll probably change that later on when they're going through the computation process. So, and then it looks like here there's your setters and getters to manage references to pointer objects and other references. There. This is the constructor. There's a couple of them here. So it looks like it goes through, creates some default values for the eyes, uses some default values if the scanline procedure is enabled. So things there. So they're defining an equality here. Most likely this the faces are perhaps checked to see if they've changed. So perhaps this is used as a comparison. So the previous state of the eyes, the face, if they've not changed, it probably won't update the display. So that's probably what the equality is for. But it could be that the eyes are held in some sort of data structure where they use equality to check for, so they don't have duplicate items for. Or I doubt they're using a hash table or a dictionary where they would use equality, because I don't see a hash function and I can't intuit what they would do that for. But I bet you this is just so they can tell if nothing's changed and they don't need to do a redraw. Some more getters. Here they're setting the values so they can copy the face structure from another object as convenience, or another instance. Then here we get to, these are the keys in the JSON file. Will probably be used below in the JSON interpreter. Set eye array helper. This is probably just a way of, so as they get the parameter for the eye and then a whole list of all the parameters for it, probably uses, goes through and updates the file there. Yep, scans down, gets each of the parameter and sets it for the individual eye. Along the way, doing some sanity checks on the values to make certain that things are correct, and then looks like it might doing some updates on the hotspot glow, where the kind of what I think of as the pupil is, and to adjust that as appropriate, or at least crudely. So here we're getting into set from flat buffer. Now flat buffer is the most common format for the animation file. It has the strength over JSON in that it does not require a lot of dynamic memory management to do it. It's very fast, and so it has low resource needs. which is makes a lot of sense to select that. So here they get, so they're just getting the parameters, and then they're using that. So they're getting the parameters from the key, from this flat buffer object, which they're all accessed through a getter, and then they're just placed into the internal local structures here using the getters and setters. And they also have the JSON one. Now, this is not if-def for developer mode. They actually just support it. It's kind of curious why they might have left that in. It strikes me as if this could have been an evolution, or they might have had a design decision, or they may not have gotten around to removing it because it was still convenient with all the tooling, or they might have had some other reason. But with the use of a flat buffer and its better resource utilization, it is kind of odd to me that they would have not just gotten rid of the JSON and interpreter here. But they're going through and they're using the particular module, and they're getting the values again, getting each of the values. If they're set, then they call the particular setter to set them inside of the instance. The reason why it wasn't done up in flat buffers is the flat buffer library actually has defaults built into it. So if it actually isn't stored in the flat buffer file to save space, it uses a default value. And as opposed to JSON, if it's not defined, this code here has to know what the value for the default should be. It's built in and it knows that it's not set, and then calls the right setter. And then here's a helper that sets it from values, all the particular values that may have been extracted from one of those serialization formats. They also can be used set from message. So I don't know where this is done yet, but it does imply that something, either a debug tool, something on the SDK perhaps, or some other software service, perhaps Vic Engine, perhaps others, can do something to set the display. It's not real clear. Maybe one possibility is the behavior tree that Vic Engine manage sets the eye parameters manually, such as the position and the scale and angle. We'll have to kind of watch for that as we go along. Here's the procedure that sets where the eye should look. This is kind of useful in a couple different ways. One of which is it tries to look at a person if it sees somebody. But also when the robot is turning, it tries to keep the eyes looking at the same thing. So the eyes will move while it's turning, which makes it very lifelike in that sense. And so they probably are calling this by something that manages the motion or manages the face world. So what do we see here? Yeah, so it sets parameters to do that. Looks like these are some sort of, they get the parameter values and they check for a range, ending the assert here, and it spits out an error message, which probably would be hard to understand if you ever saw that in a log file, what is going on there. They have a template function here to basically do a linear blend between two values at some time. So this is probably used as part of the animation steps where they have the two keyframes and over time they transition from one to the other. So they kind of are doing a linear translation here. And then this is probably used because angles probably, maybe, I could be wrong, but angles probably blend differently than the other values. So they need to be able to wrap around sensibly and, compute sensibly. Then this is the interpolation procedure. I bet you this one handles that overall animation interpolation, and it calls those others. It's interesting. What is this? So use pupil saccades. Those saccades are when the eye moves back and forth a little bit as it sweeps, usually while reading in a person. Blend fraction, so that probably controls how far between the two different keyframes to go. And it's checking from 0 to 100% to 1. They're handling real carefully if it's a floating point if it's a number that's 0 to a human being, but because of floating point representation, it isn't quite exactly 0, they probably just handle this here where it's like, it's close enough to be 0. We don't need to do any computation. Let's treat it as 0, which is a very good technique to use with floating point numbers. Similar with 1. Along the way, they have, here there's a for loop so they can do the left eye, then do the right eye, and then do each of the parameters. And then they probably go through here. Yeah, they set the parameters by blending them. If it's an angle parameter, that's what they were using that angle stuff before, was to know which of the two ways to do a blend between the keyframes to get there. And then, yeah, so it's now interesting. I don't see the difference here between these two set parameters, these two else. So if can be unset is true, it does this. And if can be unset is false, it does this. And to my initial read here, these two results are the same. It looks, perhaps once upon a time this was different code, or they were trying to fix something that wasn't working right, especially since there's a bug ID right here. And then here they go through and they probably update the rest of the values based upon the steps going along this interpolation between keyframes. And here they get an eye bounding box. So they probably are going to use this somewhere in the drawing routine to perhaps know what to clear or know what to preserve. But yeah, it's looking where the eye is, how big the eye is, and all of that, and getting a box or a square or a rectangle around where that eye will be, including all its curves and all of its squints. Set face position, that probably sets the center of between where the eyes go. Don't know what exactly is going on here. Let's see if you So I can't comment on that. I don't fully understand the nuances of what a set face position and keep centered would do. It perhaps is trying to move the eyes around, but I don't know. And here's one of those combination methods where they're combining two different eyes to get one value. They're using a linear so depending upon the operation they're doing this. We'll have to see what they use this for later on. This probably has something that creates some of the more interesting special effects with the eyes. Some are another combination, so this has both eyes in there, and it calls each of those individual combinations. And then it combines here the scanline distortion. Here's kind of gets So it says clip, but I'm not fully sure what's going on here. So it's getting the clip limits for the eye and checks that the values are within. Oh, I bet you I know what it is. I misread this as it's actually probably checking to make certain the value for each parameter is within an acceptable range, and if it's outside of that range, if it's too high, it uses the maximum value. If it's too low, it uses the minimum value. And I was getting confused here with clip being a graphics operation of trying to keep trimming a line so it fit within a box. And then they have some warnings that the value is not within there. So if you're modifying the animation file and you run it and you see these kind of messages in the log, that is probably what happened, is that your value was too big or didn't even make sense. Nan here is a value which is not a valid value. You'd want to look at the parameters there to see if there was something goofy going on, if they were out of range, or if there was a typo in the JSON file or something. Here's some warnings that kind of check that, yep, let you know that the parameter value is out of range, and that you'd want to go look through the file to kind of identify which instance of that variable was not in range and try to fix it. Okay, clip warn function. Okay, this is a little helper there. Enable clip warning. So apparently the warnings can be enabled and disabled. That's probably a developer option. And then some more getters and setters for the other methods here. And okay, this looks like this would be called at when this class is initialized, an instance there to create the scanline distorter. So it's going to do new. So there isn't a fixed single static scanline distorter. They do actually call new to create one. I wonder if they and that's because it gets changed with the noise probability or something, or these parameters, and they can't change the parameters. Or if it's just because that was a convention when they first wrote this, that they didn't need to worry about the memory pressure of an embedded system. Here's another template thing to add console variables. So what they're going to do is, yeah, register console variables. It's similar to the other one, other class looked at earlier, where it is going through many of the parameters for each of the eye, for the face itself, for the combination of the eyes, and then perhaps each of the individual eyes, and creates a text name for the variable that, and a way that the software can access it and update it from the web page. So it goes through for the console group and creates each of these, and then loops through each of the individual eyes and provides the parameters. It probably, not fully sure here. Yep. So down here, they're actually dynamically creating a string for this. So they're programmatically going through this array of parameters and creating a text name for that can be set. And that's the end of the file.